Okay, now today we're just spending another day on geometric sequences, but just like we did with arithmetic, we learned that, and then we did a day of kind of real life stuff. And today we're doing some real life stuff too with what's called growth and decay. Okay? Now, for growth, we're just talking about anything that gets bigger. For decay, people get this like thing of like a moldy banana or something fuzzy in the fridge or something rotting in the bush, okay? Decay just means it's depreciating, it's going down, okay? So you don't really say that your bank account decays, right? We said, no, it's depreciating. Or your car's not decaying. I mean, it might be decaying and depreciating, okay? So we're going to talk about, first of all, geometric growth. And what better to talk about geometric growth than bunny rabbits, okay? Now, just read that quickly and see if you can tell me how many bunny rabbits right now. 1,500, okay? So put that in the 2010 slot. Okay, now that's the easy part. Can somebody tell me how our population increases 20% every year? How do I find out how many bunnies I have in 2011? Yes? 10 over 2. That's multiplying by 5, right? 10 over 2 is 5. So multiplying by 5, I don't know if that would... Yes? Okay, so you're going to multiply by 0.2 and then add it back. Okay? A faster way to do that is to multiply it by 1.2. Okay? So if you want to find out how much GST you're going to pay for something, what do? Well, multiply by 0.5 to find out how much GST. Multiply it by 1.05 if you're going to find out how much is going to cost with the shirt and the GST. Okay? So what we're going to do is when anything is increasing, right, and everybody knows you cannot multiply by the percent. You always have to change it to decimal. You actually might want to back up like 2 seats because that's like the can't see zone. There you go. That should be better for you. You see better there? Okay, right on. Okay, so if you are going to increase, you want to add 1. So whenever you say increase, it's going to be 1 plus your in appreciation rate or your percentage. So all you have to do is go and multiply by 1.2. Okay, so how many bunnies will we have? 1,800, yep. How many next year? 2,160, okay, because then we multiply by 1.2, multiply by 1.2, so that's 2,592. Okay, now this is all cool. We're seeing, yeah, got it, chart, 1.2, 1.2. But here is the, let's go all the way down to D. And the question asks, how many would there be in 2025? Now, we know, first of all, how many years later is this? 15 years later. Everyone got that in their head? Okay, so maybe write that down. 15 years later. Now, what is the thing that's always catching us? Is that T15, T16, T14, T, like which one is it? So if it was me writing a test and I got this question, I would do exactly what I'm going to show you right here. Because I need to get it all straight in the old noggin first. I'm not just going to use some fast rule. You know what rules are? They're actually, I think no rule should exist if you can't actually think about why the rule is there. Okay? If I'm driving by and I see to slow down to 30 kilometers an hour, that's a rule, right? But I should understand the rule. And the rule is probably because I'm in a school zone. Okay? And it's probably a good speed because then I don't have to live with actually hitting a child. Okay? So I understand, I know the rule, but I actually understand the rule. So I just don't want you to say, it's T15. And I go, why? I don't know. Okay, why should you slow down to 30? I don't know. What do you mean? You're in a school. You see all the kids? See balls going across the road? You see? Get it? Huh? Okay. So, this is how I get it straight in my head. What is T1? What year? 2010. Well, we're talking from the beginning of time. Yeah, you're right. So 12 years later, but 2010 is kind of, if we take A as this, we're going to call it 20. Okay, a good question. Do you see how if you're thinking this way and we're thinking that way, that probably not going to agree with each other until somebody explains something. Okay, so what's T2? 2011. I recommend doing at least 3 so you have a very, very clear pattern in your head. T3 would be 2012. So here is the million-dollar question. What would No, it's not 20 years. Remember, we said it's 15 years later. So we're off that topic already. We're moving on. Moving on here, okay? So what's the battle? Between what 2 numbers are we battling right now? What's that? 15 and 16 we're battling with, correct? And you're always going to battle with those unless you figure out a pattern. Now, I can see it quite clearly from this. What do you notice about this number always compared to this number? This number is always, well, this number is always 1 more than this digit, right? So I think it's quite clear, since I've seen it 3 times. 1, 2, 3. I would call this T16. If I'm going to stay consistent with my pattern. So 2025 to me is 16 years later. So that is going to be, I'm looking for term 16. So that is 1500 times 1.2 to the 16 minus 1. Which is 23,110.53. Okay? So that will be the thing on the test that you're going to have to articulate. And I hope I see T1, T2, T3, the dates down till you get the pattern. You get the pattern, then you are very confident what you're going to call this. If I called this T15, you and I would be having a discussion later because I'd be like, huh? So this is always 1 more, and then all of a sudden you said, I'm going to make it the same. Okay? It should be clear to you that this is not T15. Because this should always be, like I said, this should always be 1 less, or this should always be 1 more. Okay? Now let's go to the next page. Let's talk about decay. Now decay, we're obviously going down. Things that decay, there's not as much today as there was yesterday. Or there's less today than there was yesterday. No matter what it is less. Okay? Now, here's a question for you. We got Vinny, borrows a car for $10,000. His parents lend him the money with an interest-free It is interest-free as long as he makes a payment at the end of the year. They agree on a repayment scheme which Vinny owes 10% less at the end of a particular year than at the beginning of that year. This repayment scheme lasts for 8 years. At the end of the 8th year, he makes his final payment to pay off the loan. Okay. Now, I guess what really this is saying is he's paying down 10% every year. And he will owe how much at the end of the first year? What percent will he owe? He'll owe 90%, right? He's always got to pay off 10% of what he owes. Okay? Now, is this realistic in real life? No. But it had to be done to make a math question. Okay? So, right now, he owes $10,000. Like he bought it at the beginning of the year. At the end of the year, he will owe 90%, which is $9,000. So he basically started with 10,000, and we multiply by 0.9. Now we're going to multiply by 0.9 again. He just has to pay off 10% of the 9,000. So if you multiply that by 0.9, you get 8,100. Multiply that by 0.9, 8,100. Oops, sorry, 7,290. And multiply that by 0.9, and you get 6561. Okay. So, how do we determine that 0.9? How do you get 0.9? Yep. So we subtract the 1, or 10%. So, when you have growth, okay, it will be 1 plus a percent. When you have decay, it will be 1 minus the percent. So I want to put it this way to help you understand. If I got a loan, or say I put my money in the bank and I get 10%, how much will I have at the end of the year? I will have mine plus 10%, right? So I'll have 110%. So I will have 110% at the end of that month. But if I owed money, okay, and I only paid off 10%, then I owe 90% at the end of, okay? So it's what you owe or what you have at the end. I will have 90%, okay? Now, here's what we got to do again. We have to find out how much does he owe at the end of 7th year. Now, we're so close, we should just keep multiplying by 0.9, 0.9, 0.9, done, okay? But just for the sake of learning how to do it with the formula, what should we call A? So what if we called A 9,000? What year is that? So that is end of year 1, which is term 1, correct? When is 10,000? Beginning of year 1. Why are we talking about end of year 1? Because that's when I always have to make my payment. Okay? So, what would be end of year 2? What term? Are you with me here? Okay? End of year 3 equals T3. End of year 7, T7. That's pretty clear to me. So I am going to be finding T7. Okay, so we come back here where I have a little room. T7 equals A is 9,000 times R, which is 0.9. I'll even put 0.90 to show 90%, to the 6, or 7 minus 1. And that works out to be 4782.97. Okay, let's just do these just so we can learn how to do this. So what would be my R? I'm looking for R in rate of inflation increasing by 3.5%. What's my R? 1.035. Okay, now I want hands up, okay? Let's see if you know this. Number of fish in the lake is decreasing by 2% each year. What is my R? Yes. 0.98. Good. 1 minus. Okay. Okay. Next one. Number of rabbits in population is doubling each year. Ooh. So how much more will we have next year? 100% more, right? Okay. So 1 plus 100, or 1 plus 100 plus 100 is 200, or 2. Okay. It's 200%. What if the value of a computer decreases by 1/5 each year? That means how much is it worth? We got one person that knows that. Yes? 0.8, which is, actually, if it's 1/5, then it would be worth 4/5, which equals 0.8. Good. Now the ball rebounds to 3/4 of its previous height. What would be my R? Yeah? 3/4 or 0.75. Because this one's weird, hey? Well, I thought we were supposed to go 1 minus 3/4. No, it actually did the math for us in the sentence. It says that it will lose 1/4 every time, or it will keep. So whatever it tells you it's keeping, then you're going to put that as your percent. Okay, so this is always a very good question. We got a rubber ball that's dropped from the top of a building 2 meters, 20 meters high. Each time the ball bounces back up to 80% of its previous height, calculate to the nearest centimeter the height of the ball after the 15th bounce. Okay? Now, just under A, let's draw a picture. Okay, you can do that. So draw a picture of a building. So just draw, here's my building. Okay, so it's going to be like a tall building, so put a couple windows in here, right? A door. Now again, remember when I draw this stuff, I'm a trained professional. Okay, so don't get intimidated by these drawings. A lot of people do, they see that and go, oh, I can't do a drawing that good. Just do your best, okay? And try not to get all freaked out and, oh man, that's awesome. Because you too could be this good if you did as long as me, okay? Now, we also have the ground, and you can see that I purposely made this ground a little rough, because ground usually is, okay? So again, I am a stickler for detail. See how you go with that. Now we have a ball at the top here. Yes, that is not to scale, but it's too hard to see a ball if I draw a little one. Okay? So it's like a big ball, okay? Now I'm going to drop it, and it will drop like this. Right? Now you guys know that a ball doesn't actually make those little dots. Those are imaginary. Right? So, but this is easier for you guys to see. Now it will bounce up 80% of its height. Again, this is imaginary, but it will go up this high, right? And At that point, it will come down again. And do you see how I did not go as high? Because balls lose. How did it lose energy? No. Well, that's some of it, but where did the energy go? Ground, yeah. Sound, heat, right? Okay, and then it's going to bounce again, come back down. And that's a little too high. Bounce again, come back down. Okay, so can anybody tell me what this here, what distance is this? 20 meters. So let's write 20 meters there. So we're going to write 20 meters by a little dashed line that doesn't exist, right? Because it's imaginary line. How high will it bounce? How much? 16 meters. So everybody put a 16 meters here. Okay, so why don't we call this B1? B would stand for, actually I wasn't thinking that, but yeah, it could stand for bounce. Okay, now, so after bounce 1, or bounce 1 I guess we would say is 16 meters, right? What's bounce 2? 12.8. Okay, so you're getting the idea here. Okay, so is everybody seeing what's going on? Okay, again, you might want to look at your pictures because some of yours aren't very good, like Sarah does. So we need to practice those a bit. Eh? So now this is one of those, John and Jane questions where John did it this way, Jane did it this way. What do you guys think would best be term 1? $16 or $20? Okay, well let's use it as, do you understand you'll get a different equation if you do yours as 20. So 16 times what would be our R? 0.8 and minus 1, right? Now here's the question. T1, that would equal, in our case, would equal bounce 1, right? Okay, everyone get that? So T2 would be bounce 2, which would equal, okay, so we want bounce 15. So we need bounce 15. So what term would that be? T15. Now, if you did your bounce 1 as 2,000, then bounce 15 would be term 16. Okay? So you got to keep that straight. This one, I think it's better to say, well, bounce 1, make that term 1, right? Because, but if you used 20, just make sure. And I kind of look at the bounce as the up all the time. Makes sense to me, bounce is up. Okay? Now later you're going to have to figure out total distance of this ball that it did throughout the entire thing. Okay? But that's not a long time, like it's, 23 hours away. So a long time we have to deal with that. Okay? So let's do T1 equals 16 times 0.8 to the 15 minus 1. Would it be, yes, sorry. This should be Tn here too. You guys writing this down? Okay, so what is T15? Just have to put that in and you get 0.70, 0.36. Now, that's in meters. Anyone know what that would be in centimeters? 70 centimeters. Okay? Remember, kill him dead, but don't commit murder. You're here at basic, and you have to go to centimeters, right? So you go 2, which is 70 centimeters. Okay, basic is your meter, your liter, your gram, and decigram, centigram, milligram, decimeter, centimeter, millimeter, right? You guys have used this chart before, right? What was your saying? Was it somebody dancing? King Henry danced? Yeah? No? What is it? King Henry's daughter died. No, there's different things for B. So King Henry's daughter died, but then there's another D in there. That makes sense. Oh, see, I would just do this. See, watch. Kill him dead, but don't commit murder. B is basic. B is basic, so that would be without a prefix. Meter, gram. Oh, really? Holy, that's confusing. Okay. Hey, as long as it worked. As long as it worked. Ah. Yep. Okay. Let's go to the next one. Okay, compound interest. Okay. Now, if we have $5,000, it's guaranteed investment certificate. That means that you're going to get 3% interest added at the beginning of that year, or added to the investment at the beginning of that year. Consider the geometric sequence which represents the value of the investment at the end of each year. Okay? Now, what is the growth factor here? 1.03, right? So, after 1 year, so after 1 year means at the beginning of the next year. It's within 2 days, right? So, if you had 5,000 and you put it in at the beginning of the year, at the end of the year, you would have this much, which is 5150. Does anyone recognize that number? It's the name of the Van Halen album. No Van Halen people in the crowd? No? No, you're not a Van Halen guy? No. Somewhere? Yeah. You don't know this album? Okay. Okay. Oh. Now, you don't even know who Van Halen is? You just crawl from under a rock or something? Okay, now, so when was this? This was the end of year 1, right? Okay. Now, to do the investment after 2 years, we would go 5,000 times 1.03 times 1.03, right? Now, I know what people are saying. Why don't you just take 5150 and multiply by 1.03? Because I'm trying to get to a formula here. This is the same thing as 5,000 times 1.03 to the squared to the 2. Now, this says end of year 2. Now, one thing about financial institutions, it always happens at the end of. Okay? It happens at the beginning of them if you owe them money, happens at the end of, well, actually it just happens always at the end of, let's just say that. Mortgages are different, okay? But you don't have to know that this year. So this is T2, right? Now, just want you to think about it. Do you see how here, term 2, the exponent is also a 2? Okay? So when you want the end of, let's say, 10 years, how much money you have, you would go, you'd be looking for T10, which is 5,000 times 1.03 to the 10. Now, isn't this kind of different from before? But one thing about financial institutions and the compound interest formula is that the exponent is actually always the year. And but I know a lot of people are going, well, but we learned this formula, n minus 1. Well, see, we had 5,000, and at the end of the first year, so end of first, right, this would be 5150. But what do you always count as T1? Do you ever count 5150 in your head as T1? No, you would probably say this is T1. So this is actually T2. So the end of the first, and then you'd put it into 2 minus 1, and you get the 1. So the end of first is actually T2. Okay? So I just want to show you again what I mean. So everyone look up here. So in it, let's just look at a chart over here. If we had now, okay, end of year 1, end of year 2. So now we had 5,000. At the end of year 1 would be 5150, and at the end of year 2 would be, what's 5150 times 1.03? Okay, someone got it? What is it? 53. Okay, so 53. Okay, well, that's good enough, though. We'll just, now, if we call this T1, T2, T3, and we called this A, we would still be using A times R to the n minus 1. So, at the end of year 1, to find that out, we would put a 2 in here, right? What's 2 minus 1? 1. So, the year will always be the exponent. Here's year 2, which is actually the third term. 3 minus 1 is 2. Hey, so these are always the same. So financial institutions have said, let's just make the year the exponent and not have this n minus 1 stuff. Okay? So here is the actual formula for financial, or for compound interest. A equals P times 1 plus I to the n. And n equals number of years. Because if you look above, do you see how n did equal the year? D stands for, okay, this stands for amount. P stands for principal. I stands for interest. And make sure you always put it in as a decimal. And this stands for number of years. So let's just, as an example, let's do 25 years for the above question. I would go T25 equals 5,000. It's 1.03 to the 25. Remember, the year is always, so this really, or actually, no, let's put this, yeah, we'll just go A equals, okay? Because it actually is the 26th term. You're right. So we're not going to call that. We'll just call A equals 5,000 is principal. Principal is the money you put in the first place times 1.03 to the 25. So banks always keep it easy. The year is always the exponent. But you know it as actually, that would be the 26th term, right? It's 26 minus 1 is 25, 25th year. So it just works out nice that the year is the exponent. Okay, so we're going to do 1 to 11, and omit 3 in that one, and 15 to 20. Okay? What number is that? No, you don't have to do the group investigation. Okay, don't waste time. Let's go. Again, I don't want you guys to start losing the idea that it has to be absolutely quiet in here. It's not, because it's the second week now, and